Llama 3 is finally out, and it might be one of the most important AI models out there. Although we don't have a paper or technical report yet, there is a lot of information scattered across the web now. So without further ado, let's see what we know about the new Llama model and how it compares to Llama 2. And let's start with model sizes. The previous version, Llama 2, came in 3 different sizes: 7 billion, 13 billion, and 70 billion parameters. Llama 3 came only in 2 sizes, 8 billion and 70 billion. And if you thought we're missing a model here, just wait. Meta is currently training a 405 billion parameter model, and it will be released later this year. And by the way, the model sizes can be a little bit misleading, because the number of parameters doesn't really tell you anything about the performance. Just because Llama 2 and 3 models came in similar sizes, doesn't mean that the similar sized models are close in performance. A few days ago, Mark Zuckerberg actually said this.
The 8 billion is nearly as powerful as the biggest version of Llama 2 that we released. So it's like the smallest Llama 3 is basically as powerful as the biggest Llama 2.
Right, so the performance comparison should look more like this. And the 405 will not be 6 times better than the 70, but it should be somewhere in this region. But for now, we have 8 billion and 70 billion. And like in previous models, they both come in 2 flavors, the base model and the instruction tune model. And let's quickly recap how they differ from each other. The base model was pre-trained on trillions of tokens from large amount of public data, so it contains lots of knowledge, but it will not follow instructions and can generate harmful outputs. Then you have the instruction tune model, that you get by fine-tuning the base model for helpfulness and harmlessness, using a mix of supervised fine-tuning and reinforcement learning. In addition to these 4 models, Meta released another version of their safeguard model, called Llama Guard 2. This model is trained to identify some potentially harmful content, so it can be applied to your workflow to check the inputs and outputs of your standard language model, as recommended here by Meta. Llama Guard 2 is based on the 8 billion model, and it seems to perform on par with GPT-4, so that's a big improvement for AI safety. My next point is about pre-training data, and this one is very impressive. Llama 2 was previously pre-trained on 2 trillion tokens, which is already a mind-boggling amount of data. But Llama 3 was trained on a whopping 15 trillion tokens. So the training corpus increased by more than 7-fold. And they used this massive dataset for training all their models, even the smallest 8 billion model. That hasn't been done before. Previous models of this size, like Google's Chinchilla, were trained on about 100 times less data. And these trainings are expensive for Meta, but that's how we get these 8 billion models that are as good as 70 billion Llama 2 model. And according to Meta, these trainings are not even converging, so we are not close to their real limits. Anyway, we also know the data cutoff time. When we look at the model card, we can see that the knowledge cutoff for 8 billion was March 2023, and for 70 billion, it was December 2023. They also included 4 times more code data. Of course, that should improve the coding capabilities, but it should also improve the general reasoning skills. And lastly, there is more multilingual data. About 5% should be high-quality non-English data. And of course, 5% isn't much, it is still an English model, but look at this comparison. This table is from the Llama 2 paper and shows the language distribution in the pre-training data. About 98% of the data was made up of English and code, which means only 2% of Llama 2 pre-training data had non-English text. So 5% is still a good improvement for Llama 3. Now let's talk about the training data for instruction fine-tuning. Llama 2 used over 100,000 examples for supervised fine-tuning, or SFT, and over 1 million binary comparisons for reinforcement learning with human feedback, or RLHF. I believe we currently don't know the exact amount of data for SFT in Llama 3, but that doesn't matter so much because this stage is more about data quality than quantity. If you're more interested in this topic, I recommend reading this great paper called Llama, which shows that fine-tuning with a small amount of carefully curated examples can beat RLHF. When it comes to RLHF and data quantity, that's a different story, because the reward signal is very sparse here, and more data can significantly improve the results. And in this case, we know that Meta used over 10 million human annotated data samples. And speaking of RLHF, this stage of the pipeline was slightly changed. Besides rejection sampling and PPO, the fine-tuning stage also uses direct preference optimization, or DPO. DPO is a very promising improvement, and if you want to learn more about it, I will link the paper in the description below the video. But for now, let's just say that Andrew Ng felt like giving the authors a standing ovation after reading the paper. My next point is about input tokens. You probably know that any text that goes into LLMs is first chunked into individual tokens. So for example, the text, "Please consider subscribing to my channel," gets tokenized by the BERT tokenizer into this. As you can see, the sequence of characters got tokenized into individual words, except for the word subscribing. This happens because the tokenizer uses a fixed vocabulary of tokens, and the word subscribing does not occur in its vocabulary. So it has to be compiled from 3 different subword tokens, sub, s, and cribing, that do occur in the vocabulary. That basically means that tokenizers with larger vocabularies can produce shorter sequences, because there is less splitting. And that makes inference faster. When we look at the code of Llama 3, we can see that it uses tick token, an open source tokenizer developed by OpenAI with a vocabulary of 128,000 tokens. That's a much larger vocabulary than the one in Llama 2, which uses the sentence piece tokenizer with 32,000 tokens. And Meta claims that this new tokenizer is 15% faster now. However, this new representation comes at a memory cost, and the new model needs larger input layers. That's why the smallest model has 8 billion parameters instead of 7 billion parameters now. And speaking of tokens, the new Llama model can now process up to 8,000 tokens in its context window. So it doubles the capacity of Llama 2, and that's good, but many people were a bit disappointed about this and expected more. Other language models offer a much larger context window. For example, you can have up to 128,000 tokens with GPT-4 and up to 200 tokens with Claude 3 Opus. So you won't be able to analyze the entire trilogy of Lord of the Rings with Llama 3, but that's just for now, and Meta promises to increase the context window in the future models over the next few months. My last point is about performance. Here you can see a nice benchmark comparison of Llama 2 and 3 that I found on Reddit, and as I mentioned before, you can see that Llama 3 8 billion is very close in performance to Llama 2 70. Also, look at the 7 and 8 billion models. Those are 2 completely different systems, a huge improvement over there. And when it comes to other language models, Meta released these numbers, and you can see that they overall beat models of similar sizes. And these numbers are nice, but I personally prefer the benchmarks in Chatbot Arena, where people can submit prompts and then choose between 2 outputs from 2 different models, and pick the one that is better. We actually already have thousands of submissions for Llama 3, and you can see that it's claiming the 5th rank together with Gemini and Cloud 3 Sonnet. And I think that when the 405 model is rolled out, it will challenge these closed source models for a top position up there. So all in all, Llama 3 seems like a very useful model and a great step towards capable open source models. I think that Meta did a great work here. And to be honest, I don't get the whole thing about metaverse, but 400 billion open source language model trained on tens of trillions of data? Yeah, I get that. In the coming months, Meta is promising to release more capabilities, larger context windows, and a research paper. So stay tuned, I'll try to cover these updates in my future videos. And if you like the content, please hit the subscribe button. Thank you for watching.